Okay, so we are a little bit behind on schedule, but because we did our tests during class, that's why. But we'll catch up, okay? If you remember last time we started on relation, although you have seen this in your set theory and logic class, but we'll just do some more review of this Cartesian product. I mentioned about that. And relation, let's go to the, again, the property of relation, okay? So if you remember, relation is R, it's a subset of A cross A. So you will have a set A given, and then you will have the direct product, right? Or the Cartesian product, which is a pair, then you take some subset from that and becomes a relation. So the first one is reflexive and irreflexive relation. All right. So for reflexive is AA in R for all A in A. Right? If you given A is 1, 2, 3, 4, 5, you have to look in the R relation whether you have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Right? That is reflexive. Okay, next is irreflexive. Okay. There's something missing in the notes here. A relation R on a set A is irreflexive if for every A in A, for all A in A is not related to A. Okay, or you say AA is not in R. This is the thing that is missing. Hannah, you please help me with the, okay? You cannot find, like if you have A is 1, 2, 3, 4, 5, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 cannot be inside R to be irreflexive. Okay. Now, the opposite of irreflexive is not reflexive. They are not opposite of each other. The opposite of irreflexive is not irreflexive. Okay, you just add the not reflexive, not irreflexive. Okay, if you have something like this. Right? So this is not reflexive because you don't have 2, 2, 3, 3. You always have to have a reason there. If you answer any question, you have to have a reason. And this is not reflexive since you can put 2, 2. 2, 2 is not in R, or you can write 3, 3 is not in R. Okay. Not irreflexive since 1, 1 in R. Okay, irreflexive means you cannot have any same pair. All right, reflexive means you have to have all pairs. Okay, depending on your A. It can be tricky. I can give you something like, call this R1, call this R2. If I give you things like this, okay, if I give you things like this is not reflexive because 3, 3 is not in R2. Yeah, although there's 1, 1, 2, 2, but not 3, 3. Okay, the second one is You can go through some other examples from my notes. Okay, the second one is symmetric. Asymmetric. Antisymmetric. Okay. So for symmetry, symmetric says AB in R implies BA in R. Okay, if there is a 1, 2, there has to be a 2, 1 if they're different. If they're the same, it's okay, 1, 1, 1, 1, right? If there is a 1, 2, there has to be a 2, 1. If there is no, it's okay. All right, that is what it means by symmetric. If you just have 1, 2, there is no 2, 1, meaning it's not symmetric. Okay. Asymmetric. AB in R implies BA cannot be in R. Okay, so if it is symmetric, it cannot be asymmetric. If it is asymmetric, it cannot be symmetric. Okay, symmetric means if there is an AB, there has to be a BA. Asymmetric means if there is an AB, there cannot be BA. All right, so you know there cannot be AA. All right, because if there is an AA is there, right? So they cannot be AA. For this one, if there is a 1, 2, look, is there a 2, 1? Okay, if there is a 2, 1, it can be both not symmetric or non-asymmetric. Okay, then we will see more examples. Okay, antisymmetry. Okay, this says is AB in R and BA in R, then A must be B. That is another way to write this, right? Like this, right? Or you write A, R, A. This says, if you have both in here, they have to be equal. Okay, meaning you cannot have both 1, 2 and 2, 1 inside. Okay, you cannot have because they has to be equal. So I will write one example here. Symmetric. So example, I can have 1, 1, 1, 2, 2, 1. Okay. Let me see if. Okay. View. I can do it a bit like this. Okay, then yeah, this is clear. Okay. All right, just to make sure that I'm clear. Okay, so this is okay because they are the same, right? 1, 1 and 1, 1. There is a 1, 2. There has to be a 2, 1 to be symmetric. Okay, for this one, I can have R. If there is a AB, cannot be BA. So you cannot have a double. Yeah, you can have 1, 2, 1, 3, for example. Okay, because you don't have a 2, 1. For this one, you cannot have, if they are equal, if they're both inside, they have to be equal. So this is also asymmetric, antisymmetric for this one, because this one is in R, 2, 1 is not in, it's okay, right? Then this will be false. If it's not there, it's okay. False implies anything is true, all right? If you have 1, 2, you don't have 2, 1 is okay, but you cannot have a 2, 1 for antisymmetric, because it says if you have both, it has to be equal. So, but you don't have to have this too. So you can have something like this. This is also antisymmetric. Okay, this is a little bit tricky because, okay, you have 1, 2, and you don't have this. So this is false. True and false is false. False implies anything is true, right? The implication. You remember the table? Okay. So this is an example. An example of not. Okay, let's write an example of not. If you want to understand something, you have to come up with your own example or counter example. That will show you really understand. Okay, so symmetry, I want to write not, yeah? The not symmetry. Not, I put not, yeah? Not symmetry. For example, I will put this. 1, 2, 1, 3. Why do I do this? It's the same thing. Let me write the answer here. So this one, let's go through this and go through the whole, yeah? So this one is symmetry. Symmetric. Is it asymmetric? Not asymmetric. Since, you have to write the reason. Not asymmetric since 1, 2 in R and 2, 1 in R. Since. Because the condition is it cannot be both, right? It cannot be. Okay, now is this antisymmetric? Okay. If it is symmetric with something different like this, it is not antisymmetric. Because if they are the same, if you have this, they has to be equal. But this one, true and true, but they are not equal, false, yeah? So this is not antisymmetric. Not antisymmetric. It's not that hard, but you really have to understand what it means and going through some examples. Okay, now I will go to this example. Definitely not symmetric. Because there is no 2, 1, there is no 3, 1. So that is your why. R is not symmetric since 1, 2 in R, but 2, 1 is not in R. Yeah, that is your reason. R is not symmetric because 1, 3 is in R, but 3, 1 is not in R. Either one can be your reason. You don't have to list all reason why it's not. Okay, one is enough. Okay. Kalau okay, yang on video tu gini-gini lah. Asal macam faham, tak faham. If you're not sure, geleng-geleng, then I will repeat. It's okay. Okay. If you want to repeat also, I will repeat. Okay, make sure you understand. Okay, and this one is not symmetric. This is asymmetric because that is the example of symmetric. What about antisymmetric? Antisymmetric means if you have both, then they have to be equal, but you don't have both, right? So this is also anti-symmetry. Okay, so don't confuse yourself with looking whether they are the opposite or not. Not necessarily. If it is not symmetric, it is not symmetric. Don't say if it is not symmetric, then it is this or this, because it can be both, it can be not both. All right. So if it is not symmetric, just not symmetric. If it is not asymmetric, it's not asymmetric. If it is not anti-symmetric, it's not anti-symmetric. Okay, no need to like, is it, if it's this, is it this? You just remember and understand the why. All right. Okay, so third one, there is a 1, 2, but no 2, 1, right? So this is not symmetric. This is okay because 1, 1, but you look only the different one, 1, 2, right? What about asymmetric? If there is AB, it cannot be BA. But there is a 1, 1, right? So if there is a AA, it cannot be asymmetric. Because 1, 1 in R, of course 1, 1 in R. Okay, so you can put a note here. Cannot have AA. Okay, because if there is a 1, 1, definitely there is a 1, 1. So it is not. So cannot have AA. To be asymmetric. Okay. For antisymmetric, if you have this, they have to be equal. Meaning cannot have AB, BA. Both in there. Yeah. Okay, cannot have both different. I don't put AA, I put ABBA. This one is directly need to have AB and BA. Okay, let me give you one question and you answer whether it's symmetric, asymmetric, or anti-symmetric. I give you a simple one. Simple one. R equal A, I have to give A, right? A is 1, 2, 3. R is 1, 1, 8. One, 1, 2, 2, 3, 3. Okay, let me give you a few minutes to think. Okay, the easy one would be reflexive, right? Okay. Let me, sebab nak bagi markah bonus kan, so I have to call your name, the easy one, Fatana. Fatana, this one, easy question. Is it reflexive?
Yes, Prof.
Yeah, because AA in R for all A in A. Just copy this, right? AA 1, 1, 2, 2, 3, 3. Okay. Next would be Nur Alia Zulkifli. Is it irreflexive?
No.
No, because you have 1, 1. Okay, or you have 2, 2, or you have 3, 3. Okay. Okay. Next would be Alia Afika. Is it symmetry?
Yes.
Yes, because
1, 1, 2, 2, and 3, 3 in R.
Right? 2, 2, 2, 3, 3, 3, 3. Yes, symmetry. Okay. Neha? Is it asymmetry?
Yes, Prof.
Cannot have AA. Yeah, so the answer is no, not asymmetric. Because you have 1, 1, you cannot have 1, 1. How can it be? Right? So you cannot have a AA. Right? So it is not. Why I did not write the answer? Yeah. So it is reflexive. Macam soalan test 2 tau. Irreflexive. Not irreflexive, yeah. Not irreflexive. Symmetric. Okay. Not asymmetric. Okay. The last one is anti-symmetry. Siapa yang tadi saya tak panggil? Seni. What about this? Is it anti-symmetric?
Yes, Prof.
Yes. Yes. Because you don't have any different pairs. Okay. The one that you have, they are the same. It's okay. Because you have AB, you have BA, 1, 1, and 1, 1, and 1 is 1. Okay. So yes, it is anti-symmetry. Okay. You will get used to this, but you need to do more examples, look at more examples and see the reason. Yeah. If there are any examples in the notes that you are not sure of, please ask in the next class. All right. I'm not going to go each and every one of those. Okay. After this, I will call students who did not have their video on. Okay. Fair kan? Okay. Kalau tak nak dipanggil, cepat-cepatlah on video. Saya panggil yang tak on video. Okay, next I will go to number 3. It's not hard, but you need to understand, yeah? This one is actually quite straightforward, but it can be confusing also. ARB and BRC imply ARC, or AB in R and BC in R, AC must be also in R. Yet again, if you don't have this, if this is false, this is okay. You don't need to check. But if you have these two, you need to check for this one. Okay. Okay, let me see. Okay. Let me see, I give you one example, yeah? Let me copy this example first. A is 1, 2, 3, 4. Okay. Okay, so I give you the relation, yeah? So R 1 equal, let me give you the easy one first. 1, 2, 2, 3, 3. Okay, R2, 1, 1, 1, 2, 2, 3, 1, 2, 3, 4, 1, 4, 4, 3. Another 1, 3, 2. Okay, so you want to see whether this is transitive. Okay, if you have all mutually exclusive, meaning they don't connect, right? There is AB and there's a BC. You need to find AB, BC. The two has to be the same. Then you check whether the first and the last are there or not. So for this one, you don't see any connection, right? Because they're all different. 1, 1, 2, 2, 3, 3. So this one is yes, transitive. Okay. All right. And for the other one, you have to check every pair that can connect. Okay. So for 1, 1, you have to find the 1, 2, add up like this. Okay, so 1, 1, what starts with 1? 1, 2. So you see these two. But if it's AA and this is AB, you will get AB, right? AB. So you don't have to check the AA. Don't need to check. So you will check the one that's different. So check these two. 1, 2, and 2, 3, right? 1, 2, and 2, 3. So is 1, 3 in here? Do you see 1, 3? Angguk kegiling. Okay, so you don't see a 1, 3. So you stop. So it's not transitive. You don't need to check the rest. Okay, so you check these two. So not transitive since you write 1, 2, and 2, 3, right? 1, 2 in R and 2, 3 in R, but 1, 3 is not in R. Okay, because there is no 1, 3 here. So if you find 1, meaning that it's not transitive. But if it's okay in there, suppose I add another question, okay, R3, call it R3, in which there is a 1, 3. Okay, so I put R3 here, I add 1, 3. So you want to check again whether it's transitive or not. Okay, so you start with this 1, 2. 1, 2, 2, 3, there is a 1, 3. Check, right? You go to 1, 2 again, you see any 2? No. So you don't need to check. So you go to the next one. 2, 3. You go to 2, 3, and then you want to find 3, right? To connect. You see 3? 2, 3, 3, 3, 2. 2, 3, 3, 2. What do you get? 2, 2. Right? 2, 3, and 3, 2. That is in R3, but 2, 2 is not. So it is not transitive also. Okay, yeah? Okay. You on video, you can do, you understand. Okay. Let me try once more. I want it to be okay. So I want to add 3, 3, and then I'll check again and again. Okay, I changed the question, yeah? Just to show you. So let me just call it R4. And I add 2, 2. Suppose 2, 2 in here. So to show it's transitive, it's not easy. You have to check every single possible pair. Okay, and how do you check? You don't need to check the 1, 1. So you do 1, 2, 2, 3. Just now, it's 1, 3. Okay. 1, 2. Is there any more 2? Yes, but this is 2, 2. You don't need to check. Then you go to here, 2, 3. So you think 3, 2, 3. There is no 3. You have to go from the beginning, yeah. 2, 3, 3, 3, 2. So 2, 2 is there. Okay, check. And you go next. 1, 4. 4, right? 1, 4 means the second one is 4. So 1, 4 and 4, 3. You see 1, 3? Yes. Okay. Anything else start with 4? No. Done. Then you go next. 4, 3. 3, 4, 3, 3, 2. Then 4, 2, right? You don't see a 4, 2? So again, it's not transitive. Okay? But I want it to be transitive. I add another one. Okay, so, but I have checked until I have been until here, right? 4, 3, 3, 2. So 4, 2 is here. Okay. Then I go here, 3, 2. You don't go just that way, but you have to go back. Okay. Now you start with 3, 2, 2 here. 3, 2 and 2, 3. 3, 2 and 2, 3 means there is 3, 3, right? But you don't see a 3, 3. So still not. If you want it to be, then you have to add another. I'm not saying that you have to add. I mean, if you want it to be transitive, but this is how you have to check every single possible pair. Okay, so this is the hardest one actually. If it is not there, then you stop. You remember the very beginning when I give you the example, it's just short, right? So you check one, it does not work, then it is not. Okay, so remember, if you want to find transitive, don't go to the one that it has. Go think first, go straight to the one that it does not have. Then that becomes your reason for not transitive. Let me go back. You can go the coordinator, but let me go back to the original. Suppose I just have this question, yeah? Okay, so suppose you are given this question, I just call it R2 or R prime. You see, from the very beginning, 1, 2, and 2, 3 is in there, but 1, 3 is not. Right? So you stop, not transitive. So R prime is not transitive since 1, 2 in R prime and 2, 3 in R prime, but 1, 3 is not in R prime. That's it. Okay. The one before I added because I want to show you it can be transitive if we have enough the third pair. Okay. Okay. All right, enough on these properties because this is a very basic. Okay, if you don't understand this very basic property, then it will be hard later on. And why this is very important, because a common question, probably in the test, probably in the final, is to show that R is an equivalence relation. This is very, very important term. Okay, even if you do research, not under this class or any outside, you see the word equivalence relation. This is what it means, and this is what you have to prove, that it is reflexive, symmetric, and transitive. Okay, these three. So you have to have that this is reflexive, symmetric, and then the third one is transitive. Okay, so you know if the question is just one, but you have to actually show three things. All right, okay. That is another term that we call partial order relation. Partial order. Okay, thanks. Partial order relation. The difference is the second one. This is reflexive antisymmetric, and then transitive. Okay, so your task is to go through the examples, or examples, there's so many of them in the book, and there is also a solution, but don't read, meaning go through the question, try to write out the solution by not looking, and then you check. Okay, it is okay to get it wrong because that is how you learn. Okay, the solution is given there with the reason, so you can easily check. So after this, I hope all of you can go through the examples in the notes. Okay, I will go next to partition. This is also very important, not only just for the set, just for this class, but after this, when you do research or you continue your degree, if you hear the word equivalence relation, after this you hear the word partition, then you're supposed to know what that means. So I will go to partition. Okay, before that, let me check. I thought I give matrices somewhere. Okay, maybe later. Yeah, later. Okay, let me go. Just go to the partition. I'm sure you have seen this so many times. Okay, so suppose S is a set and you have subset, yeah? And AI is a subset of S. And how many do you have? I1, 2 until N. So you have A1, A2, A3 until AN subset. Okay. Then, so normally when you see definition if then, it actually means if and only if. But people will just write if or then. If that is the word definition, that means you can go either way. Yeah, if and only if actually. Okay, so then AI is a partition of S. Is a partition of S if, okay, definitely cannot be empty. Yeah, we don't want an empty subset. And they are mutually exclusive, meaning they don't intersect. And their union is the whole set. Okay. We are mathematicians, we don't get scared with the symbols, right? This is how you make things simpler, in which you can write out each subset is not empty, they don't intersect, and the union is the whole set. So easily, if you are given something like this, right? Then you can partition into different subset. And you can partition so many different times, different subsets. I mean, if you want to have one a subset of order one, meaning just one element inside, right? So you can have A1 to be 1, A2 to be 2, until A6 to be 6. This is the smallest number in the subset, right? 1, 2, 3, 4, 5, 6. So they are all not empty, they don't intersect. It's like cutting a cake. Okay, it's like cutting a cake. You cannot cut like okay, and the union is the whole thing. Or you can do a subset of all the two elements inside, right? And that you can choose many, like 1, 2, A1, 1, 2, A2, 3, 4, A3, 5, 6, or like 1, 3, any two, but don't intersect. Or you can have 3, 3, right? 1, 2, 3, 4, 5, 6, or 1, 2, 6, so many. Even 3, 3, so many. You can also have 4, 2, or 4, 1, 1, right? You can have 2, 1, 1, oh, so many subsets. So that is all partition. Okay. Now, another one is equivalent class. Okay, equivalent class. Partition is an equivalent relation. Okay, partition is an equivalent relation. And then you have equivalent class of A if it's connected, related to A. Okay, that is equivalence class. Okay. Okay, last one I think is the matrix of relation. And with all of this symmetry or not symmetry, you can draw the matrix. And last part is digraph. Okay, let me go to the matrix. Matrix is equivalent relation is the matrix of relation. Okay, that's page 87 here in my notes. Okay, matrix of relation. Okay. Now you have a set X until M, you have a set Y until N, and you have a relation from X to Y. Just now, the set X and Y are the same. That's how you can do like symmetry. They cannot be different because they have to map. But this one is a different from X to Y. It can be any two different sets. And the matrix M sub R is has entry Mij. And you find the Mij to be 1 if AI, Bj is related 0 if AI, Bj is not. Okay. Example. Example, I have to give example of X. X say 1, 2, 3. And Y is say A, B, C, D. And I have to give you the relation. Suppose this relation is 2A, 3B, 1C, 2D. Okay. If they are related, 1. If they are not related, 0. So the matrix has only ones and zeros. Okay. So your matrix M sub R. So you will have the 1, 2, 3 here, right? And the A, B, C, D here that you don't see. I and J, right? I and J. So I is the row, J is the column. I put this one first. 2A, 3B, 1C, 2D. Okay, the one, so you have 1, 2, 3, 4. So you have 4. Okay, so this is the matrix. Easy, right? So you just match, but you have to be given R. So sometimes you are given R not in the set of a pair like this. You are given A is related to B if A is the son of B. Something like this. Okay, so you have to think in that sense. So if A or B means A is the son of B. Okay, so my children will be related to me for all of them because I have 3 sons. Okay, so the first one, if I have different X and Y. If I put me here or my husband here and my sons here, so they are all related to us. Like 1A, 1B, 1C, right? 2A. If son number 1, son number 2, son number 3, the parent, right? Mom and dad. So we will have 1M, 1D, 2M, 2D, 3M, 3D. But if your siblings have girls, right? Then some of them is not the son. So it's not, you cannot match all. So in that sense, I can ask you, is it reflexive? No, because A cannot be the son of A, right? It is not symmetric. If A is the son of B, B is not the son of A, right? Okay, it's not transitive. If A is the son of B, B is the son of C, A cannot be the son of C, right? It's the grandson. So this kind of question can be changed in general. Okay, look through, because the time is up, look through the properties of matrix relation, and I will continue with that just a little bit more, just to match up. If it's reflexive, then I have one, right? If it's reflexive, if you have a square A to A, if it's reflexive, right, you have all ones there. If it's symmetric, it has to be symmetric AB and BA, those kind of things. So read through until the end. I will continue that tomorrow until the digraph is quite straightforward. And then I will start chapter 3. Okay.